statistics. I'll share with you a small document that can help you to understand the language of statistics and mainly the terms involved in that particular field. Statistics is our day-to-day thing in that we cannot separate ourselves from data, okay? And when it comes to now the correction of that data or the information, analysis of it, organization of it, and even drawing conclusions about that particular data, then we define what we call statistics. It is a field where we correct the data, we organize it. For example, we can have it in form of tables. We can also have it in form of charts. We analyze it after we have done the organization of it. We analyze it. That is where we do the calculations of, for example, these elements we are calling averages. And once we come up with those figures, we now make conclusions, or we can use that information to, for example, conclude about a particular case. And that is all about statistics. Data can be corrected from two ways. One, you can get the information from the whole population, and this is what we call the universe. And if we are correcting the data from the whole population involving all elements in a given area of study, then we are talking of what we call census or a complete enumeration. This is a form into which you correct the data from every other element that is part of the population. Like I may say, I go to KCA University and I query or I investigate a particular case from all the students. If I go by asking every other student a question, the data that I'll get is sourced from the form we call census or a complete enumeration, where I have covered every other part of that particular population. But I may fail to ask all the students at KCA questions. It is going to take me a lengthy time. It is too much for me. Maybe it is even expensive. So what do? I may narrow down to, let's say, only one area. For example, I ask questions to only the banking students. The banking students who are part of KCA will give me what we normally call in statistics a sample. And that sample now helps me to gather the information, but I'll use the information got from that small group we call a sample to now make the conclusions, to now make the inferences about the whole population. Like I may say, I want to know whether at KCA students participate in extracurricular activities. So I've just asked questions from one class, the banking students, and now I'll make a conclusion on whether at KCA students do participate in the extracurricular activities or not. So a sample is actually preferred in case you want to do a quick analysis about your area of investigation, and sometimes you want to narrow down the cost that will be involved when you're doing your analysis. So for us, we'll be having what we call a sample. Data has been already provided. We will not go into the field to correct the data, and now we go into the calculations of some elements like the mean, the median, the model value, standard deviation variance. Yeah, all that will be based upon a small group of what we call the sample, okay? So once we have that information already provided, the information is the one that I'm calling data. Data, by definition, is low information, provided which is not actually organized. We are the ones to organize it when it comes to the statistic field, okay? So we'll start by looking at what we call the mean. And mean by definition is defined as a value which is got by you taking care of all the observations in a data, all in a distribution, and then you divide by the total number of the elements in that particular population or the sample, whichever could be involved. So how do we define, let's say we have a given data set, and by definition, a set of data, this whichever we are calling data set, this is just but some information actually corrected, but it is not yet organized. For example, after, let's say we have done an exercise in class, I will write down against each one of our names how many marks you have attained from that particular exercise. So if I say Mary has 20, James has 30, I keep on writing down those marks. The data that I get forms a set, and that is what we call the set of data or data set. So when we have a set of data, how do we go about finding the mean? The mean will be given by, we sum over the data variables, and then we divide this one by the total number of elements in that particular sample. For example, we may have a figure of 20. Let's say we have a variable of 30 as our marks got in a class. Let's say we have a figure of 11, and let's say we have another value, somebody has gotten a total of 9 marks. All these, we'll put it together, you sum over, and then how many students are constituting my set of data? There are only 4, so I'll come and divide by 4 as my number of elements in that data set. And the figure that I'll get here is now called the arithmetic mean, normally denoted as X bar. I repeat, X bar is the figure we call the arithmetic mean in statistics, and this is denoted by get the total number of elements which have been involved in that particular analysis, sum them over, divide by how many they are. If there are 20, you put the value 20 here. But remember, you're summing over every other element. And even if there was a student, let's say he had a 0, what we could have done here would still have constituted the 0 as part of the addition. But now we divide by the total number of elements involved in the study would actually be 5. So don't miss any in case you're talking about the mean. One of the advantage about the mean is that it involves all the elements in a given area of a study. That is the correction, the data set had how many elements. If there were 5, remember to add all the 5 elements. If there were 10, you do the same as you define your mean. So mean in general is a total of all the elements in a certain set, and that total is divided by how many elements are in that particular set. I've given an example here. There are some retired workers in a certain organization whose retirement age was recorded as follows. We have the values of 54 and all the way to 60. So if I'm asked to find the mean, what do? I will sum over all these elements. There are 11 of them, and I'll come and divide by the total number being 11. So the mean is now coming to 56.6 years, though you can confirm this as you do the calculation during your free time. Okay? The other thing that I want us to imagine is would want, let's say, to have this particular data now organized. How would I compute its mean? Below that particular document, I've already shared this one through your email a few hours ago. There was an age of 54. The 54 is appearing how many times? We can go back to this data set. It was appearing 3 times. The age of 55 is appearing only once. The age of 56, that of 57 all the way to 60. So what I've done here, I've organized a small table, and it can be useful in the computation of the mean. So what will I do? Let's see what we are going to do here. I'm going to add another column. The term that I'm calling frequency here is the number of times each and every element is appearing in the data. We saw 54 appearing 3 times. So I'm going to baptize this column that we call frequency as column F. This that I call column H, I'll call it column X. So that here I can come and I find what is the column X multiplied by the corresponding value of the age, in other words, X. So I'll take 54 and I'll multiply by 3. It will give me a value here, 54. I'll multiply this one by 3. I'll come and write it down. I go by, and you don't do this actually, you represent the result, okay? We are multiplying X by F column. Each, you do the corresponding elements. Then you go to the next one. We have 55 multiplied by 1, which will still give us a figure of 55. And you do all the way to the last element in the last law, so that here down, you can now define what is the total of the column F of X. Or the variance F multiplied by the corresponding X will now give us a total of what? So this figure, let us assume you have found, and I want you to do this during your free time. Let us assume here you have found something like 590. I'm not saying that this is the result. I want you to make as an assumption for now, but to make the correct deduction there. So if I have a table already arranged in this format, or myself, I can do a simple arrangement of such a data set into this small table. How do I come up with the value that we are calling the mean? Our X bar, the mean, will be given by, you take the value we are calling the sum of the F multiplied by X, and then you divide by, you come back to this column known as the column F, the frequency column, you actually find the total. So here I'll talk about the frequency sum, or F of X. And again, you'll find a result here. It should be 11, but I want you to confirm during your free time. So you come and divide by the sum of the frequencies. And that result becomes the mean, which I want you to confirm that it is the same as the figure we had found, equivalent to 56.6 years during our free time. So when we have a simple table like this one, this table is called a frequency distribution table. We haven't gotten to the point of grouping it. So this is just but called a frequency distribution table, where you just arrange the values appearing in the data set, and then you ask yourself how many times that each of the values is appearing in that data. If it is 3 times, like the 54 years here, you actually write down the frequency to be 3. The number of times that each and every data value is appearing is the one we call the frequency. To find the mean, I've said from a simple frequency distribution table, you take the column frequency multiplied by the corresponding value of the variable being represented. In this case, it's an age, which I've assumed it to be X. You take the column frequency, you multiply by that corresponding X value. There down, you find the total. You go back to the column frequency, make sure you know the total number of observations, the total number of items in your study, and then to find the mean, we take that total of the frequency multiplied by the corresponding values of the variable, divide by the total number of elements in the analysis, and that becomes our mean. So mean, for now, we have looked at it in two ways. One is where we had the data set, where we have said just sum over the variables, 20 plus 30 plus whatever the other figure will be, then you divide by how many there are in that data set. You may construct a simple frequency distribution where you take the frequencies as the number of time to which an element is appearing, and to find the mean now, you take the total of the frequencies multiplied by the corresponding values of the variable, divide by the total number of frequencies, or rather, the total number of observations in the data. And that becomes our mean value. Our next point to look at the mean will be now we incorporate the group frequency distribution. But that one will be our next meeting. I want now to introduce another average that we call the mode. And mode is actually a value that appears, and before I forget, during our free time, we read through from our document the advantages and the disadvantages associated with the mean as a measure of location. Mode is a value in a data set that appears most of the times. I repeat, a data value that could be appearing most of the times is the one we call the model value. And I'm hoping you are writing down because as I do my presentation, there is some work that I'm also incorporating. Make sure you are able to understand what we are talking about, okay? So our model value, we have said, is a figure that appears most of the times in a given data set. So you just evaluate, or you just look at the data, which among these variables it is appearing most of the times, and that figure becomes your model value. For example, I may have a data set. Let us assume here we have figures of 3. We have another one, let's say 5. We have another one, let's say 1. We have another one, let's say 7. We have another one, let's say 3. And maybe we have another figure. Let's assume we have 2. So when we are looking at the model value, we'll come and look at these data variables, and we ask ourselves, among these, which one is appearing many times, maybe beyond others? And as you can see from our data set here, this is a good example of a set of data where the data is not organized. Each and every element appearing has been represented. This is a data set, and as you can see, 3 is appearing 2 times beyond any other element that is constituted in the data. So in our case, our model value would actually be 3. And because here I have only one model value, my mode here is equivalent to 3, which is only one model value. This is an example class of what we call a unimodal kind of a data set. Unimodal is a case where the mode represented in that data is only one. So we call it a unimodal data set. If there were two model variables, for example, where there are two variables in your data which are appearing with the most highest value or times, then we say such a data set is biomodel. I repeat, if for example, we had a case, let us assume in our data here, we had, let's say, 35173. Then I had, let's assume, 2 and maybe 8. If you are to come and look at this data set and you ask yourself, is there a figure that is appearing most of the times? Yes, 3 is appearing 2 times beyond any other, and 2 also is appearing 2 times. So if we were to write down the model variables, then we would actually say our model variables are the model variables are 3, they are 3 and 2. And because there are 2, what kind of a data set is this? This is an example of what we call a biomodel data set. Biomodel means we have got 2 data variables which are appearing with the highest number of occurrence, and there are 2 of them. If there were 3, what do we call such a data set? We'll call it triomodel kind of a data set. If there were 3, I've said you call it the triomodel kind of a data set. And if they go beyond that number, say 3, we define this one as per the number of model variables. So if there are 4, you just say this is an example of data set with 4 model values. But if there is only 1, we say triomodel, or rather unimodel, sorry. If there are 2, we talk about biomodel, and if there are 3, we talk about the triomodel kind of a data set. Our time is over, the one provided. Not terminating the class. I want to continue a few more minutes. So when we are logged out,